So here we have a picture of the MMS orbit in what is called its first phase, where the orbit radius is about 12 Earth radii. And I mentioned that we have to have a tremendous volume of data to catch these very small regions. And such that, in fact, we cannot get all this data to the ground from the spacecraft. Now, that may seem hard to believe, but you may remember from your cell phone, last cell phone bill, that if you try to make a cell phone call from Europe back home to the United States, that costs a lot of money. And in fact, that's because for most of that data, you're actually transmitting it up to 6 Earth radii in space and back down to Earth. Okay? And that data transmission, even though infinitesimally small compared to what we're talking here, is expensive. It's the same for NASA. Anytime you transmit data, you have to have a whole ground system on the ground, people managing the antennas, recording the data, recording where it goes, transmitting it back to a central data station. It's an expensive proposition to ship data around. Such that, in fact, in MMS, of the regions where we expect to find reconnection, we can only send down about 2% of the data. And so we go through a mode on board, a processing on board, to try to identify these regions, to so-called produce critical trigger data, to identify these regions. A slower rate data is transmitted to the ground. On the ground, there are other computers looking at this data, computing whether each of these regions is something that we want to transmit to the ground for extensive analysis at this very high data rate. And this whole mechanism, this whole burst mode mechanism we call the burst system, is an elaborate mechanism to allow us to identify and get the critical data to the ground and to ignore the less critical data that we can't afford to transmit.